classroom. If not, you can leave, of course. This is our new lecture room of our physics department. Everything is brand new. So enjoy this lecture room. You might feel the floor looks some flexible. It's a multi-layer, anti-shock design. Because this room is quite large, I do not encourage you to enter from this room. This door is for emergency exit only. Okay? So I will lock. Just for emergency. Emergency. Okay. Okay. The floor is flexible. It's shock absorber. Why? Because the floor of this lecture room is quite large. They will have a low frequency vibration. That's the first problem. The second problem is below this lecture room, we have a very delicate experimental facility. We must be very gentle. Walk like a king. Yeah, don't jump. Okay, don't jump. Don't jump from first step to the floor. Don't jump. Inside this room, you must walk like a king. Okay, remember, keep this in mind. You can speak loudly, that's okay. Because the frequency is different. Let's afraid of low frequency, low vibration frequency. Okay, that's the first one. Our department spent roughly about $5 million to remodel this lecture room. Okay, I will show you. $5 million was donated from class 1969， 1969级的学长姐捐的。We show the design of this lecture room, and they say, "Wow, great, no problem, no problem, that's good, just do it." Okay, so the design is visualized is quite important. You should give them some vision, and then they will be happy to give you money. Okay, and you can enjoy this new classroom. We have 10 air conditioner. 10 air conditioner. More than, and some fan. Okay, so the circulation in this room should be much better than room 019. So air conditioning should be much better than 019. Okay, that's our hope. Because 019 is in the basement, the air conditioning, no circulation. So you will easily feel asleep. But here you have no excuse. Okay. My name is Chunxu Zhang. Chunxu Zhang. Zhang Chunxu. Okay. This is a required course. Required course for our physics department should be given in English. That's our strategy. Okay, so all the required course for the graduate school should be given in English. So I will present in English for more than 50, more than 90 or 95%. For most of the time. This is the fall semester. 秋季. And my telephone number is 42978. Email is shown here. Yes. No problem. You can ask in Chinese or English or Thai. 就到听不太懂，勉强。
好 ，OK。我只是问一下，能不能用中文
？Okay, you can ask any question. Okay, in English, Chinese, or Taiwanese, or I will say I don't understand. You have to change another language. Okay. We have an office hour. Office hour is about 1 p.m. to 3 p.m. right after the class. So today is Tuesday and Thursday afternoon, 1 to 3 p.m. I should be in my office waiting for you, in principle. But unfortunately, I am very busy. For example, this afternoon, I have to go to the Ministry of Science and Technology, 科技部, to attend a meeting this afternoon. So obviously, this afternoon, I won't be in my office. So if you want to 加退选 how to translate in English? If you want, you have other business, come next time. Okay? My office is in this building, 4th floor, 417. 417. Okay? We have 2 TAs. The first TA is Xu Hongjun. Please raise your hand. If possible, stand up. If possible. Okay. Hongjun. Okay. He is the former TA of this course. Next one is Outset. Okay. You should clap your hands. That's the email address. These 2 TA will help you a lot. Outset. Quite long, right? That's the first name. And that's the family name. And that's father's name. Okay, maybe Outset you can pronounce your name for us.
This Outset, certificate breaker source.
Slow down.
It's certificate breaker. It's very hard to pronounce. So you can just call me Outset CJ.
Outset CJ.
Yeah.
Okay, in short. Outset CJ. This is pronounced as Joseph or Joseph. Okay. In comparison with Outset's name, my name is quite simple. you should pronounce my name correctly. Zhang Chunxu. Okay, keep this in mind. Okay, classical electrodynamics. Outset, your office is in the general building 2. Okay, and Hongjun, Xu Hongjun, his office is up to this one. 119. 119. Okay. 118 or 119, but most of the time he stay in the 119. Okay, not too far. This is the description of the course. We have studied electromagnetism in actually several times. When you are high school students, you learn electromagnetism phenomena. And for university, you learn at least twice. The first time is general physics 2, when you are a freshman, you learn electromagnetism once again. The major difference between General Physics 2 and high school electromagnetism is English, right? Because General Physics 2, the electromagnetism of General Physics 2 is quite similar to high school electromagnetism, except the language. Language is the first barrier, but it's not that difficult. Okay, for General Physics 2. However, for freshmen, you have to study calculus. So you know what is the differential equation, what is operator. So when you are sophomore students, you learn electromagnetism. And at that time, you try to change the integral equation to differential equation. Okay? Try to simplify the notation a lot. Change the notation from integral equation to differential equation. From integration to differential equation. Integration is an overall picture. However, differential equation is localized phenomenon, localized event. You can simplify the calculation a lot. Okay. By doing so, the physics is still the same, but the mathematics will be much more difficult. Therefore, that's the first problem you encounter here. And what's new? What's new in this course? Electrodynamics. The major difference is the physics is always the same. Fundamental law is the same, but the physics will be, but the mathematics will be different. The language we used will be different. So you can study the same phenomena using a different language. You can study in more detail, different perspective. Okay, in that case, you will see a completely new world. Okay, so we will introduce a very powerful techniques called the green theory, green function. That's a very powerful tool, the green function. With this tool, you can solve electrostatics, magnetostatics, electromagnetic and radiation problems. You can solve all the problems, almost all the problems. It's a very powerful tool. Powerful means it can solve all the problems, but the problem is how to find the green function. Yeah, that's the problem. But anyway, if we find the green function, we can solve everything in electrodynamics. Okay, eventually we can solve very simple green function, just like this one. That's the green function. Okay, so you will learn the green function, and you will learn not just you will learn everything. Learn the process in Cartesian coordinates, 直角坐标系统. And you will solve the problem in symmetrical coordinate, 圆柱坐标系统. And spherical coordinates, 球坐标系统. But if you want to deal with spherical coordinates, you need spherical harmonics. Spatial functions. Not that easy, right? Okay, and if you want to solve cylindrical coordinate, you have to learn Bessel function, Hankel function. And if you want to study green function, green theorem, you need to study delta function, the property of delta function. Okay. Therefore, that means if you want to study the physics inside, you need to learn some mathematical tool. And those mathematical tools are quite useful because you will have a chance to use this coordinate in hydrogen atom. Okay, that's quantum physics, quantum mechanics. And you will use cylindrical coordinate in optics and many different fields. So that's the spatial functions, maybe useful spatial functions, not just for electrodynamics, but almost for all of physics course. For all of physics course. That's why electrodynamics is so important. Okay. We will use, the textbook we use is this one. Classical Electrodynamics, 3rd edition by J.D. Gibson. J.D. Gibson. Okay, so that's the first one. The most important textbook we will use. This textbook has been published for more than 30 years. I said more than 30 years. Okay. Very useful. And luckily, you can find electronic version for free. Okay. But if you like a hard copy, I think this is quite important. I have 3 copies of Gibson. Yeah, 3 copies. 1st edition, 2nd edition, 3rd edition. Second, our reference will be this one, Griffiths. He said Griffiths. Introduction to Electrodynamics. Okay, this is the 4th edition. But you can use 3rd edition or 4th edition, doesn't matter, up to you. Okay, Griffiths is the textbook for electromagnetism. For many universities, almost all the universities in Taiwan in physics department use Griffiths. But some universities, most of the universities use Griffiths. I like this textbook because Griffiths and Gibson are good friends. And Griffiths spent a lot of time to tell Gibson, you have to change your system of unit. So Gibson eventually changed the Gaussian unit to SI unit. Yes. Otherwise, you will learn SI unit for undergraduate and Gaussian unit for graduate course. Personally, I prefer SI unit because I'm experimentalist. More like an experimentalist. Convenient. Because everything is normalized. Like epsilon is 1, happy. Mu just 1 for vacuum. That can still provide a notation a lot. But for experimental, it doesn't matter because computer can help you a lot. So don't worry. And not just physics department, engineering department, material material science department, they use SI unit for most of the time. Therefore, if you want to communicate with them, we better use the same language, SI unit. Okay. Last one is Feynman lectures. Feynman lectures on physics, volume 2. Okay. Feynman described the electromagnetism, electrodynamics from different viewpoints. And his understanding about electromagnetism is quite different from these two textbooks. Because these two textbooks is bottom up. Just give you some special case, and try to find the governing rules, and eventually can simplify to a simple rule. Feynman, on the other hand, starts from here and give you some special case. Different approach. One is bottom up, give you a lot of examples, and try to understand the physics behind this special case. Try to understand the underlying physics. Feynman, on the other hand, is different. He plays a role just like a god. He defines the rules first and tell you, oh, these are special case. Different approach. Okay. If someday you become a god, try to define the rules by yourself. Okay. But the problem of Feynman lecture is no example, no exercise. So the problem is you will familiar with the physics, but you don't know how to solve the problems. I have a big problem. When I was an undergraduate student, I studied Feynman lectures a lot. I spent a lot of time to study the physics. Looks like I understand everything. But when I take the exam, I am very slow. Too slow. So I worked very hard to study electromagnetism, but my grade is just 80. Very disappointing. Yeah, very disappointing. And later on, I take this course, Electrodynamics, again. At that time, I know, oh, exercise is quite important, especially for electrodynamics. You have to practice math effort. Okay, so we will have one textbook, two reference, and sometimes you need to some mathematical tools, some lecturing, and others may be used for Q&A, quiz, and TA. Okay. If you have no other questions, TA will answer the homework assignment for you, one by one. We have 2 TA, so TA will help you a lot. Okay, that's our plan. If you are very hungry here, okay, you can leave. You can leave here. And that's okay. But if you are eager to learn, you can stay here. I encourage you to stay here to follow TA solution strategy one by one. Okay, that's brief. Okay, I will assign homework to you. Yesterday, I sent the lecture notes to all of you. Got it? Yeah, through ILMS. I send the homework to you through ILMS system. We will use ILMS for this course. So lecture note, electronic version of the lecture note has been given to you. So you can study anywhere. And you will find we have a homework. And doing the homework is the best way to master the concept of the electrodynamics. If you want to learn the physics, the best way is to doing the homework. Not just copy, not just try to solve the problem by yourself. Try to solve the problem. Maybe you can find a solution somewhere. Actually, you can find a solution for Gibson. And you can find a solution of Gibson easily. But the problem is you have to study by yourself. Otherwise, try to just not understand the physics, but just remember the physics, remember the solutions. That's not good. Some of the homework problems might appear in the midterm exam or final exam, but in slightly different form. For example, the number is different. For example, 2 or 3 problems will combine into one. Okay, so homework are quite important, but you don't have to return the homework to TA. You don't have to. 给你作业，但是你不用交。Okay, you don't have to return the homework. The conduct of the course. Lecture notes will be projected sequentially on the screen during the class. And we will emphasize the physical concepts only. And algebraic details, 代数或数学的 details, in the lecture notes will often be skipped. Okay. You have to study the algebraic details in advance. Okay. Some of the students worry about using the PowerPoint because using the PowerPoint, some professors, some instructors will give you a lot of information. Don't worry here. Roughly about 6 pages per hour. 6 pages per hour. The speed, roughly about 6 pages per hour. Not too much. So every class, roughly about 10 to 12. to slightly change. If you ask a lot of questions like you, maybe I will have a good impression on you. And if you ask roughly about 68 or 69, don't worry. Yeah. Okay? But however, if you are just 60, you still have to worry. It's still too low. Okay. The overall score will be normalized to reflect an average consistency with other courses. Okay. So, let me tell you a number. Last year, the fail rate is try to reduce the fail rate to 10%. I will work hard to set you, to help you to reduce the fail rate. However, the most important thing is yourself. You have to work hard, study hard. Otherwise, no one can save you. You have to save yourself. Let's cooperate. Let's work together to reduce the fail rate. Okay? Okay?
Okay.
Speak loudly.
Okay. Okay.
Reduce the fail rate to 10% or 5%. That's good. In that case, maybe next year, we don't have so much students here. Okay. The lecture notes. We will start from the basic equations. And lecture note follows Gibson's closely with algebraic details built in. Equation number, the same. Okay. Section number, these are the same. Okay. The technical terms which are introduced for the first time are underlined. Okay, that's the lecture notes. Where is the clock? No clock here. This new classroom is not perfect. For example, I cannot write anything here. Not good. Actually, they should lower to here.
可是像这样，你要吞下去，好像也可能困难。
吞下去总比跳起来好。It's impossible, right? Maybe sometimes we can do something like that. Maybe it's possible. It's a good idea. When we design this whiteboard, we want to make this large enough because many professors expect to have a very wide whiteboard. And therefore, we design a very wide whiteboard. Okay, but we do not consider the height of the whiteboard. That's the problem. I'm sorry. At the stage here, but at the stage here is a little bit dangerous. We designed this floor for professor, for example, is障碍英语怎么讲？ PhD qualifying exam. Good grade means the score is A- or better, A-, A or A+. And the overall ranking is in the top 30%. If your grade is A- or better, then you can waive from the PhD qualifying exam. That is, if your score is good enough, you don't have to take the PhD qualifying exam. If you want to study, you want to be a PhD student. Okay. We just give you this new channel. In the old time, almost all the students have to take the qualifying exam. And now you have a new channel. Study hard and you pass. You just pass. So qualifying exam, the students who take the qualifying exam, in the old time, roughly about 20 students. Right now, just 2 or 3. Because most of the students pass the course because they have a good grade. Okay.
教授，请问一下，刚刚你稍后说到说，就是现在有很多好像这种电脑可以帮我们算这些问题，那就是他们电脑用的这些数值方法，你上课会提到一下吗？就是我们电脑是怎么算的？还是说就是用这些学的这些技巧去做吗？还是有其他的演算法？
这句话不应该跟你们讲，应该告诉你这个秘密。这个很漂亮的数学，很漂亮的 powerful， 但是不见得好用。OK， 所以实际上在用的时候，你们会用 commercially available software for most time。
那它们里面的原理是？
原理大概都是 finite difference, finite element, and check the boundary conditions. If the boundary condition is correct, then everything should be correct. So let's just check the boundary conditions only. So I will tell you the boundary condition over and over again. That's the most important thing. Boundary condition must be correct.
那你实际在做研究的时候，比如说电脑跑出一个结果来，那就是是不是也是需要用一些什么物理直觉什么去判断这个结果？
Yes, that's right. I will show you if you study some problems, how to do that. You have to check everything. Check your solution is correct or not. Check your boundary conditions. Check initial conditions sometimes.
So our target is to solve the differential equation and check boundary conditions. And green function is just a technique to help us to solve the differential equation.
Green function is one of the techniques to help us solve the solutions, solve the problems. Yeah, one of the techniques, but it can, in Chinese is 无道一以贯之。我只要知道 green function， 全部我都可以解。Yeah.
So our problem can be reduced to find the green function and then once know green function and we can solve anything given all equation for the system if the system is given by where to find the boundary condition.
Yes. So if you find the green function, then you can solve anything. But the green function is not that easy. This is the most easy green function. Yeah, the easiest green functions. How about other green functions? Other green functions are quite difficult. Yes.
Are there any cases where the green function does not exist?
cannot find the green function. Obviously.
No, but one thing is not finding it, another thing is just not existing. One thing is being
You can always express the green function, use the spatial function, expand the green function used in the spatial function, but not convenient for most of the time. Not convenient. It does exist, but very difficult to expand the spatial functions. Okay, for example, if you want to study your cell phone, you want to study the electromagnetic field inside your cell phone. Nobody will use green function because the structure is too complicated. Too complicated. That's almost impossible to find a nice and elegant green functions. But if you study the empty space, just like outer space, this is the simplest green function. Because boundary is very, very, very far away. Infinite space, very, very far away. So this is the simplest green function. So for hydrogen atom, for astronomy, for astronomy table, this is really good green function. Okay. Green function is very difficult to find. I will give you some green function with spatial symmetry. Not too much. Not too much, but I will give you some green functions. Don't worry, most of the case green functions are quite simple, just like this one. Our green function is too dirty. No one like that. We prefer to use computer. Yeah, we have a very convenient computer. Okay, so don't worry about the green function.
等一下，教授还有一件很重要的是，
Yes.
考试应该都是 close book 吧，对不对？还是可以 open notes 还是？
For fall semester, I prefer closed book. For second semester, I prefer partially open book or open lecture notes. If possible, maybe you can write everything on an A4 size paper.
你说这学期吗？还是下一学期？
Let me think. We still have time, right? It depends on the problems. Depends on the problems. Okay. Today we will introduce introduction and tell you how to evaluate. And we will talk about introduction to electrostatics. And then we will talk about boundary value problems, chapter 2. And we will have a mid-autumn festival. And quiz is roughly about here. Quiz. And quiz is chapters 1 to 3. Chapter 4. And then we have a midterms. Midterms is chapters 1 to 4. And chapter 5, chapter 6. Chapter 6, we will talk about Maxwell equations and macroscopic electromagnetism. And chapter 7, we will talk about plane electromagnetic waves and wave propagations. Wave propagation. Okay. We will talk about 7 chapters only. And when we will have some time, I will invite some people to our course to tell you how to use computer, how to use software. For example, HFSS, high frequency structure simulator, can solve almost for most of the case. For HFS, I will invite someone from CST, Computer Simulation Technology. They can solve all the Maxwell equation problems. But maybe give you an idea. HFSS roughly about 2 million per suite， 一套软体大概要200万。Okay. CST roughly about the same. Okay. And for electrostatic and magnetostatics, roughly about 3:1, 0.3 million new Taiwan dollars. Okay. But if you can write the answer by yourself. Let's price this, right? Okay. That's for your reference only. The practical schedule will depends on your learning status, learning condition. This page is quite important because it helps you to evaluate your learning conditions. You can evaluate your class participations. If I divide the class participation into 0, 1, 2, 3, 4, 0 means you are not here, you are always absent. 1 is present and try to respond when called on, but does not offer much. When I called your name and you can say something, that's just 1. That's the minimum requirement. You demonstrate very frequently involvement in the discussions. Okay. Right now, we have 120 enrollment. 现在教室里面的学生有120个 ，too much. So it's impossible to ask you to ask question. Very difficult. So I will consider how to evaluate your class participations. Okay. And 4, here is the demonstrate excellent preparations. You analyze the case. It's exceptionally well, rating into readings and other materials. You study very hard. Okay, that's 4. Okay, this is class participations for you to evaluate your involvement. Okay, I just told you my undergraduate electromagnetic score is not good, just 80. Not very good. Compared with other courses, almost is. Compared with other courses, my electromagnetic is not good. And then I took electrodynamics when I was a senior. I was senior student. Professor Jim Nestor told me 20 plus years ago, maybe close to 30. And he studied gravitation, cosmology. So I studied electrodynamics, not studied the physics, but studied the mathematics. Because he knows very little about the physics. But he knows the mathematics very well. So I took his course to study the mathematics for me. Next time, I took this course again when I was a graduate student. Next time, Professor Ko Chong-san, he told me electrodynamics from different viewpoints. Because Professor Ko Chong-san is an experimentalist. He taught electrodynamics from different viewpoints. Okay? And I learned a lot of physics. And later on, I became a PhD student. I took the course offered by Yan Aiger he tried to organize everything well. He tried to, at that time, I'm familiar with the mathematics, familiar with the physics, and so I can enjoy the electromagnetic at that time, third time. And Yang Aide received the Outstanding Teaching Award of Tsinghua University. 严爱德教我们的电动力学那一届，他得到杰出教学奖。OK， that's not easy. Okay, Professor James Nestor, he was retired and he received the Special Contribution Award from the Physics Society of the Republic of China, Taiwan, in 2015. 物理协会特殊贡献奖 ，not because he taught me, not because. Also, I separate by one line. Okay, he received the award because he is a Canadian, 加拿大人. He come to Taiwan for more than 30 years. Okay, and he is an editor for Chinese Journal of Physics. He actually very nice person.
Sorry.
Yes.
Yeah. The thing is, if you ask that, according to what you say, you have to learn electrodynamics from osmotic perspective and from physical perspective. So, what is the most interesting things you stick in electromagnetic?
Most interesting.
Or most beautiful or most awesome, magic, whatever. You pick up something or
After studying electrodynamics, you will have a better understanding about our universe. Yeah, you will have a much better understanding about our universe. Using everything can be simplified to a simple rules. And actually, Maxwell equation together with Lorentz force equation can solve almost all the problems, including quantum mechanics. Some of the quantum phenomena can be explained easily with EM wave. Yes. For example, tunneling effect. Tunneling effect can be explained from the viewpoint of EM wave. So you will find almost everything is related. Almost everything, statistics, mechanics, and quantum mechanics, electrodynamics, everything is related in a wave phenomena viewpoint. Okay, so you will have a better understanding about how our universe works. Yeah, try your best if you take this course 3 times. So don't worry. I remember when I was an undergraduate student, my score in electromagnetic is not good, right? Just 80. And I think I don't like this course. I don't want to take this course again. Because I spend a lot of time, but he don't respond to me. He just give me a 80. What? Because most of the students got 90 or 95. Yeah. Because most of the students got very high score because they have to do the homework. I don't. I don't at that time. No one tell me I have to do the homework. Now I tell you, you have to do the homework. Otherwise, I'm sorry. Otherwise, maybe you will become here. Okay, any other questions? I would like to emphasize one thing. Because of COVID-19, if you don't feel well, you can. I won't check your attendance.不会点名哦 ，Don't worry， 不会点名。We will upload our video to YouTube. I will send you the link because some of the students are still not here in Taiwan. Maybe two or three students are still in the foreign country. They cannot enter Taiwan. Okay, so I won't check your attendance. If you don't feel well, just stay home and study remotely. That's okay. That's okay. Okay. If you you don't feel well, remember to put your face mask on. Okay. 一定要戴口罩啊 Be careful. Okay. Any other questions?
教授，你要不要用个麦克风什么？因为我以前经验好像这样子，收音好像有点差。
我们看最后面的听得见吗？
不是，我是说这个收音，这个录影收音，对，好像会杂音很多之类的。
我正在试，因为我们这个 distance 不太远。哦，我们这边有最好的4个麦克风 ，1, 2, 3, 4， 而且不会有 interference， 号称不会有 interference。
号称。
我们在测试的时候一切 OK， 都不会有 interference， 所以声音是很清楚的。但是有这么多 scatter 这么多散射物在这边，你就不知道了。因为每个都是 absorber， 都会吸收声音的。所以有这种情况之下会怎么样？至少我在测试的时候，教室没有很严重的 echo。现在跟你们讲话应该也还好，对不对？后面的 Sina, can you hear me? My voice is loud enough. Yeah. Okay. Should be okay. 如果你听不清楚的话，再跟我讲，我再也许用个麦克风吧。如果坐在最后一排的好。好。Any other questions? We still have roughly about 18 minutes. Yes.
You just mentioned that we have wind function as most of the time as electric and trivial form. Yeah?
Yes.
So, what is the situation that we will use the wind function as an integration form or differential equation form?
Just to give you an example, this is the simplest screen function. And this screen function can be expanded into cylindrical coordinates, spherical coordinates. And you can use Taylor expansion. So this screen function will be expressed in at least 4 expressions. And different expression has different applications.
So we use the same form for different example. We will use different forms to explain it.
Yes. This is the fundamental green function, but we will expand this green function into different structures, different shape, different expressions, different eigenfunctions, for different applications. Yeah. The original green function is just this one. So don't worry too much about the green function. Any other questions? Okay, if no other questions, questions, I will show you Green's theorem now. Okay? Green's theorem is a powerful tool for treating electrodynamics, electrostatics, boundary value problems. It's a simple application of the divergence theorem. You know this is the divergence theorem. Integration, volume integration can change to surface integration. Enclose this volume. Okay? A dot N dA. This is the normal direction of the surface. Integrate all the space, all the surface. This is the divergence theorem. Then we will substitute A into phi gradient per side. Phi gradient per side. This is pronounced as phi. This one is pronounced as per side. And phi and per side are arbitrary functions of the positions. It depends on position. Later on, it depends on position and time. Okay, later on. But now, just depends on positions. So, divergence A becomes divergence phi gradient per side becomes phi Laplacian per side plus divergent phi. Gradient phi dot gradient per side. Okay, so A dot N here is phi gradient per side dot N. You can stop here, or you can express in this form. You can stop here, okay. But some of the textbook, especially Gibson, he tried to simplify the notation, so it expressed in this form. 这边比较好懂，这边一点都不好懂，纯粹是数学，纯粹是好看，纯粹是为了省一点点空间。But not convenient at all. Okay. Now, substituting these two expressions for divergence A and A dot N into the divergence theorem, we obtain the Green's first identity. Green's first identity. Just substitute going into here. And this one is the simplified notation of this one. Okay, that's the Green's first identity. Okay, what's next? Next one is change phi and the psi. Phi and the psi. A becomes A equals psi gradient phi. Okay, what will happen? We interchange phi and psi. This one, okay, interchange. This one the same. And this one change to here. Phi, phi. Okay. It's still the Green's first identity. And then, what's next? This one and this one is interchangeable. So, if this equation subtract this equation, we have this one here, cancel. This one here. That's the Green's second identity. Okay, so Green's theorem starts from divergence theorem, and then substitute phi gradient psi gradient phi. Okay, and that's the Green's first identity. That's the Green's second identity. We can stop here. And if I tell you, we can simplify this one. Or, for example, let this one to be 0. one to just one terms. Can we simplify Green's second identity further? Yes, we can do that. We can do that, also do that. That's the Green's second identity. Green's second identity. Okay? We may convert the Poisson's equation into an integral equation. How to do that? For example, psi becomes this one. Okay. What's the difference between this one and this one? This one, you handwrite everything. So, handwriting is not convenient. We use boldface. But for typing, it's very convenient. Therefore, handwriting I prefer to use an arrow here. Okay. That's the major difference. Notation. Remember, it's a vector. It's a vector. Okay? How do we express the vector? This is a vector. Okay. We already know that, but yeah, in principle you should know that, but I'm not sure. Laplacian 1 over x minus x prime is equals to the delta function minus 4 pi delta x minus x prime. You should learn this expression when you are undergrad, when you are sophomore. 大二的时候有看过吧 ？Right?
Yeah.
And then phi be the electrostatic potential phi. Phi is equals to this one. This is Poisson's equation, right? This is a delta function, and psi be this one. Phi be this one. Okay? And substitute this one into here, this one into here. Oh, what will we have? We have minus 4 pi phi. Minus 4 pi here. Minus 4 pi delta x minus x prime times phi plus minus rho minus minus. So it's plus rho here. Rho depends on the source term. Epsilon 0. And this is 1 over x minus x prime. Absolute value. Okay. These three. And then this is the notation. Just substitute here. And x is inside the volume V. That's the volume. Let the surface enclose the volume. 一个体积，啊，这个是把它包起来的面积。Okay. So after integration, this one, when x prime equals x, it gives us a simple relations. Phi can move to the right, move to the left. Phi of x equals 4 pi epsilon 0. 4 pi epsilon 0, so it becomes here. addition to this one, we have two extra terms. Okay, extra terms. Okay, it's not, looks like we do not simplify the problem, but we generate some problem. But remember, this is a finite size. If the size is very, very large, infinite, 无限大, then phi will becomes to 1 over r. And this will become 1 over r. And this is also very, this one and this one are very, very small. The contribution from the surface is very small. In that case, we can simplify into this one. Okay, so this is for infinite space. 无限大的空间. Not for finite space. For infinite space, yes. But remember, this is a complete equation. We have, in addition to these terms, we need to consider the contribution from the surface. Two extra terms. Okay. That means if we want to deal with finite space, we need to consider the contribution from the space. Contribution from the space, from the volume. And we need to consider the contribution from the surface. Okay. But initially we have one term. This from Newton's. Very similar to Newton. Gravitational force. Gravitational potential. And we already know this term. But these two new terms, we don't know. The problem is, can we simplify these two terms? Yes, we can do that. If we find the green function, 0, then we can simplify the equation a little. Okay, I will stop here. So the Green's theorem is actually very simple. Divergence theorem. And substitute phi gradient psi gradient phi, and subtract these two terms. We got Green's second identity. And Green's second identity is here. And if we substitute psi and phi and psi into these two equations, we can rewrite it into this form. And we know this form already. And we have two extra terms from the surface. These two extra terms just come from the contribution of the surface. In the old time, we do not consider the contribution from the surface. But now, we will consider the surface contribution. Okay, that's the major difference. In the old time, when we are undergraduate students, we just consider all the space. But now, we consider finite space and the surface enclosed. Okay, I will stop here. Not too much, 10 pages. I will give you a hard copy. The hard copy is limited number, so you must be show up next time to get the hard copy. Otherwise, 这是限量版的哦，写完就没有了。好，不要帮同学拿哦，只有现场才可以拿。下礼拜四应该会好。Okay. Any other questions?
Identity together into the form of another how can we understand the meaning of the internal terms or
Let me show you. If you substitute phi into Laplace equation equals to 0. Equals to 0, this is 0. In that case, you still have some value. For example, this classroom, no charge inside, but we have potential here. We have potential here. And then we can calculate the potential inside this classroom. Okay, from here. Yeah, that's potential.
our task is to solve the potential in the free space.
Actually, just give you an example. For example, this classroom is grounded here. Grounded. 全部接力. And then we have a charge here. We have a charge here, somewhere here. Okay, we have a charge here. How to calculate the potential inside this classroom? We don't know. Actually, we don't know. It's very complicated. Very complicated. However, with the green function, you know there is a charge here. And you know a special function that we can find a green function. And then we can calculate this case. So if we, all the techniques, very difficult to deal with a problem like that. However, with the green function, we can deal with the problem. We can deal with this problem easily. OK？ 还有没有其他的问题 ？No TA time, right? And I have to leave almost 10 minutes from now. 还有没有其他的问题？
我是可以请大家，就是你那个讲义是怎么念？因为我记得你是1、2、3是这样，然后你好像念成这样读，对不对？可是这样子好像会有点小，字有点小，我就想说你要不要就是把它变成，就把语音了啊，算了，读了。
还好，那个字还蛮大的。
哦好。
应该还不小，大家的眼睛应该都还